Morning, my fabulous chemistry students. Let's get into video number 2, unit vocabulary for boot camp. Your learning target for today. I can define the specialized vocabulary for the boot camp, the unit. So here we go. First word, meter. The fundamental unit of length in the metric system, it does equal 100 centimeters. A liter is the fundamental unit of volume in the metric system. It is also known as 1,000 milliliters. The gram is the fundamental unit of mass in the metric system. So how much stuff do I have? I weigh it, mass. And then mass is the amount of matter in an object or sample. There is a difference between mass and weight, and that has to do with gravity. And we don't get into weight much. We talk about mass, how much stuff. So volume is the amount of space that the matter takes up. The space is the volume. All words, this is really all words you know already, right? Density. This is a ratio. This is the amount of matter per unit of volume. The equation is in your reference table on the very back page. Density equals mass divided by volume. Good. Precision. Being able to do the difference between precision and accuracy. They're both similar, but they're not the same thing. Precision is how repeatable is your measure. Do you get the same number each time? So the best analogy for precision and accuracy is darts. If you get all of your darts to go into the same area, you are precise. But if you're aiming for the bullseyes and you are nowhere near there, you are not accurate. So give them to all go in the same place. If they go all over the place, then you are not precise. See the difference? So accuracy is how close is your measurement to the accepted value. So if you're aiming for the bullseye and you hit a bullseye, you are accurate. So it's good to be both. And in science, we actually want precision more than we want accuracy, because with the high-end science apparatus, whether it's an HPLC or it's a viscometer or whatever it's got a computer attached to it, I can put in a generic fudge factor to make it accurate. I just need the same number every time. If I can get the same number on the same sample every time and have precision, then I can fudge the accuracy. Okay, put in a fudge factor into the math that the computer's using to tell me what that number is. Okay, how close is your measurement to the accepted value? All right, matter. Matter is not what's the matter. Matter is the stuff, all things that are made of. Matter occupies volume. Okay, volume is the space that it takes up. The matter is the stuff in the space. It's kind of together, but different, right? Element. An element is a unique kind of matter, cannot be broken down by chemical means. Notice that's in bold, cannot be broken down by chemical means. That is something that is normally on a Regents question. Which of the following cannot be broken down by chemical means? You need to know that that is the definition of element, and so you're looking for an element, not a compound. So an element is something that is the same atom. It can be two of the same atom, like say oxygen is O2. That is an element. But then when I combine that oxygen with carbon to make carbon dioxide, CO2, now I have what's called a compound. This is matter made up of more than one kind of element. It can be broken down by chemical means. I can chemically make carbon dioxide into carbon and oxygen, for example. Or more importantly, we can make water into hydrogen and oxygen. That's much more common. I don't know how common it is to make carbon in oxygen or carbon dioxide. We do the other all the time. Okay? A mixture is two or more substances put together. They are not chemically linked. Therefore, they can be separated by physical means. So if you think of sand and water, or even sugar and water, they're not chemically linked. The sugar is dissolved. I can't let the water evaporate, and the sugar crystals will reform. The sugar won't go out into the air when the water does. So I can separate them by physical means. And we'll get into some of the different physical separations a little bit later. Okay? A heterogeneous and a homogeneous mixture. These are two kinds of mixtures, and we're going to get into these again later in the year when we get them into a little bit more in depth. But for this unit, we're going to use them to help us first understand the word, and then second, kind of foreshadow what's going to come. So a mixture, or a heterogeneous mixture, hetero means different. So a mixture that is not the same throughout or settles upon sitting. If you take sand and water and cap it, shake it up for just a second, that sand and the water is mixed evenly, but you set it down and eventually all the sand falls to the bottom. And I look in there, I see two different things: heterogeneous. Okay. Homogeneous is slightly different. Homo means same. That's what that means. So a mixture that is the same throughout and will not settle upon standing. So Kool-Aid, sugar water. Kool-Aid is sugar water that's colored. Okay, really. So if I take sugar and water and I stir it up, the sugar dissolves. But when I set that cup down, the sugar doesn't just fall to the bottom. If you put so much sugar in that some doesn't dissolve, that's a different story. We're going to talk about that in solutions. That's a different phenomenon going on. But if you just put one spoonful of sugar, stir, it dissolves, set the glass down, the sugar does not fall. It's made a homogeneous mixture. It's the same throughout. When I look at it, I can't see on the top and the bottom anything different. I don't see particles in there. It's dissolved. Okay? Pure substance. Matter composed of one element or compound. It can be all a compound. Water is a compound. Can I have pure water? Sure, I can have a glass of pure water. All that's in there is water, but it is a compound. So it doesn't have to be just an element, but it needs to be every neighbor has to be the same. Okay? A particle diagram is a picture that represents the matter in a given space. And we generally use these to differentiate between elements and compounds, mixtures of compounds and elements, and then we can use them to represent phases. Okay? Phases of matter, solid, liquid, gas. And we're almost done. Go through some of the separation techniques. Chromatography is something we won't do a lot this year. But it is a separation technique that separates the solute from solvent based on particle size or polarity. You did this in a living environment. During one of the labs, we needed to put the paper down in the cup and the pigments of the leaves, and the liquid would run up the paper and they would separate because the big molecules would stay in the bottom. The smaller molecules would travel farther through the paper, and you could separate the different pigment colors. That's called chromatography, and there's many different kinds: liquid, paper, gas, chromatography. Filtration is a simple technique that separates a heterogeneous mixture based on solubility. So if you had a cone with a paper in there and you had sand water, you could pour the sand water in, the water would go through, the sand wouldn't. So that's based on particle size and the fact that it didn't dissolve. And it's also heterogeneous, or it won't work. If you mix sugar and water and you pour it through, because the sugar dissolved, the sugar would go right through the filter with the water because it dissolved in really, really tiny molecules. Okay? Distillation is something that sometimes ends up on the test, so this is a big thing, and I'm hoping that I will have the glassware to do that for you later this year. This is a separation technique that separates two liquids based on boiling points. Water boils at 100 degrees. Alcohol, like ethanol, boils at 80 degrees. So if I heat the mixture of alcohol and water up to 85 degrees, that is hot enough to make the alcohol boil off, not hot enough to make the liquid boil off. And then there's a condensing tube, and we'll show you what a distillation is later on in the notes for this particular unit. Percent error is a calculation that tells us how far away the measurement is from its the measured value versus the accepted value. And I can say I had a positive percent error, I had a negative percent error, I came in higher than I was supposed to, I came in lower than I was supposed to. And it's just that's a quick calculation we use, and we'll use it for all of our labs. Did I get the number I was supposed to use? That's it. So study your vocab words. Let's get that first vocab quiz out of the way. Take as many times as you need. Remember, you got to get an 80 or better, and that'll become second nature before too long.